Hello and welcome to HashiTalks Build. My name is Mo Khan. I am a senior software engineer on the Dependabot team at GitHub. Today I want to talk about a story between Dependabot and Terraform and how you can use Dependabot to keep your Terraform projects up to date. There's three sections to this talk. I'm going to give an overview of what dependencies are, how to identify changes in dependencies through versions, and then we'll go through a demo using Dependabot to keep a Go modules project up to date, as well as a Terraform project up to date. So it's a bit of code. Let's be pretty quick. Let's see what happens. All right, so let's create a brand new project here. We're going to use Go modules. And many projects, when they get started, they have very few dependencies or zero in many cases. So let's create a project. This is going to be a very simple project that really just says prints hello world to the terminal. And we're going to slowly level up this program to include some dependencies and just take a look at some of the reasons why we would include dependencies, etc. But this should be like a simple enough example that we can use. So you can see here, all it does is just print to hello world to the terminal. And great, ship it. First version of our brand new project. It's ready to go live. Now, as time proceeds, I found this nice little package called Logris, which adds a couple of nice features. So I'm going to pull it in. I'm going to pull in version 1.0.0 here, and I'm going to use it to print that same output to the terminal. But it's got a few nice features in it that I think I might be able to use and extend. So I'm just going to add my first dependency. No big deal. We'll use it to like upgrade our project, and look at that. We are, we're rolling. We're rolling. Now we've got like the log level, and we still got that same hello world. Now, there were a couple things I had to do in order to pull in this dependency using Go mod. You can see there's two files that were modified, or three actually, the go.mod, main.go, and go.sum. And we'll go through what each of those files are in a moment. So what exactly is a dependency? Whenever we work on a software project and we've got code that either we've written or someone else has written that might provide some service or value to our software projects, we can choose to import those pieces of software as a software dependency, either as a source code from Git or through a package registry. So when we get started, there typically isn't very many dependencies. And when you're working on greenfield projects, it feels quite free. You feel quite youthful, quite young. You've got a lot of freedom in terms of being able to make changes. So you add your first dependency, and it's not a big deal. You don't really understand the full scope of responsibilities that you may have like actually assumed by pulling in your first dependency. And then maybe time goes on, and you pull in a second dependency. And that second dependency, well, it has needs too, and perhaps that second dependency depends on another project. So you're also including in the dependencies of your dependencies. So as time proceeds, you've now got your dependencies, your direct dependencies, your indirect dependencies, that are your dependencies of your dependencies. Soon that word's going to lose all meaning to me. But okay, not too bad. We can sort of like reason about all these things. But as your software continues to grow, over time, you might find that the dependency that you had included previously, it had zero dependencies, and then over time, it started to add dependencies. And so if you want to upgrade that dependency in your local software project, you also have to bring in these new dependencies. So now you've got your direct dependencies plus your indirect dependencies plus the indirect dependencies that haven't been added by your direct dependencies yet. Over time, those dependencies may add more peer dependencies, and hopefully those decisions are done in a way that aligns with your software project and you're comfortable with. It's possible, however, that you may encounter dependencies that also depend on the same dependencies but have conflicts due to version constraints or pull in malicious code that you didn't quite realize because they had poor controls over how they publish their software packages. And you could end up with crypto mining code in your software projects and not really even realize it. Over time, you might actually realize or notice that in your software projects, you've got dependencies, more than one dependency that actually does the same thing. And you have to ask yourself, what are these? Why do I have two of these dependencies that both do this thing for me? Okay. Um, it's possible that you'll also include like dependencies that are so old that have been there for so long that you're unsure of like whether or not you need it or not anymore, or if it even works, or if it's even getting updates at all. You may end up finding yourself spending more time fighting with your dependencies than actually using them, in terms of just keeping them up to date, trying to understand what are the updates, where are they coming from, why they're important, whether or not you need them. You might incur bug reports that are coming to you that are actually related to your software dependencies. You may end up having to fork those dependencies and keeping your own copy that you can't upstream back into those dependencies. So after enough time working a software project, you might end up with dependencies that you just don't even understand why they're in the first place. Like, why do we need this dependency that prints ANSI color codes in our web project? I don't know, but it's there. And all of this can leave you sort of feeling very overwhelmed, sometimes very confused. Whew, that's a lot. And an example of a project that isn't that old. It has a lot of dependencies. Let's just take a quick peek at GitHub CLI. No big deal. So if we look at the sum file, we can see there's about 400 plus lines in here. And this is a fairly small project. I mean, it's well established. It's used quite a few people. It's a really important project. But even it has quite a few different software dependencies. And multiple versions of those dependencies, and just looking at the list of dependencies, it can be kind of overwhelming to like understand what each of those dependencies do. And some of the cryptic names of software packages doesn't make it easier. And so if you just want to get a sense of like what you're shipping, sometimes it's kind of unclear. It's a little bit unclear as to what you're actually depending on. One thing to like note, when you choose to pull in a dependency into your project, those dependencies have needs, and you are now sort of taking on responsibility for meeting the needs of those dependencies. And so younger self may have thought, okay, well, these dependencies weren't a big deal, but as you get older, you realize that dependencies have vulnerabilities. And those vulnerabilities, if they're exploited, they don't just target the dependencies, they actually target your software because your software is including those dependencies. So now you can get into like the areas of software project lifecycle where now what seemed like an innocent enough dependency to pull in over time can actually cause you more headaches than you want. But with that said, let's go back to that original project. This time, I want to add a new feature. So I don't want to just print standard out anymore. I want it to print using JSON formatting because I need to be able to ingest these log lines as JSON input, and I want to be able to have the freedom to add additional like unstructured fields in the future. I also want to include timestamps, and for whatever reason, I think I want to print out timestamps that are that take the current time and subtract a year. I'm not quite sure why, but the pandemic year, I want that year back, so I'm just gonna rewind a year and pretend that this is still 2020, and I'm just going to go ahead and print out timestamps from last year. I mean, that's a reasonable enough request. So I found, like, in the loggers gem, there is a way to override the default timestamp using this with time function. Now, unfortunately, it's only available in a newer version of the loggers, not gem, but package. So I can upgrade this repo to use version 1.0.6, and ta-da! You can see, like, I'm now actually just printing timestamps that are a year old. Woohoo! However, I've also included additional dependencies due to the upgrade of loggers from 1.0.0 to 1.0.6. That may or may not have been intentional, but I'm going with it because I want it and I need to ship this thing. I need that year back, so I'm going. Let's just go. Let's do this. So so far this project started off just printing to standard out, and then we included the loggers package so that we could actually format things slightly differently. Then we updated the loggers package so that we could print JSON output as well as hijack the timestamp to reclaim the lost year. Okay, so far so good. Now, that was just like one reason to upgrade a software dependency, but there are many others. And some of those changes include new features that are available in the software package that I might want to take advantage of. There could be bug fixes that were fixed in the software package that I'd like to include. And in some cases, there's like significant new features or refactorings that require breaking changes. And so in order for me to make sure that I stay up to date, I may need to keep my software dependencies or upgrade my software dependencies so that I don't fall too far behind to the point that I can no longer receive bug fixes or new features. Now, there's this idea around versioning called semantic versioning, which is a way to signal to the community the potential reason why a new version of a piece of software exists by just using the numbers that are in the version itself. So the semantic version is as simple as this, and for the most part. I mean, there are some edge cases, but it's made up of 3 numbers delimited by dot. And the first number indicates the major number. This is the major version number. So anytime that that number increments, it can represent like a breaking change. It usually represents a breaking change, and therefore that usually means that in order for you to upgrade your project to that version, it may require you to make some changes on your side. And that might mean configuration changes or changing the API that you're using because it's deprecated or changed. But it usually requires some intervention from you in order to be able to upgrade. There's usually a benefit as well to upgrading the major version, aside from just making sure that you can get the latest bug fixes as well. But there is risk involved in terms of upgrading the version number. The next number that I want to talk about is the minor number. That's the second number in the semantic versioning scheme. And this represents the addition of new features to the software package. This is meant to be done in a way that's backwards compatible. So it should be lower risk in terms of needing you to actually make changes in your software program or project to be able to pull it in. So you should be able to pull that in without any real disruption and receive and be able to utilize new features in the library or program. And finally, the last number is the patch number. So this represents a potential bug fix that was patched and released. So when this number goes out, a bug was fixed, and you should probably upgrade. It's also meant to be backwards compatible, and it should be the safest upgrade that you can do in most cases. So this when you see bug fixes go, you typically want to upgrade and pull those in, as long as the project adheres to the semantic versioning standards. Let's go back to our example project here. And I want to just talk about these two questions that you're likely going to encounter when you're discussing your software dependencies. And the first question is, what dependencies do you want to include or use? And what is the range of versions of those dependencies, right? So what dependencies and what versions of dependencies do you want to use? And the second question is, what versions of dependencies are currently being used? And so when we look at the go.mod file, this file is sort of like the file that's used by developers to indicate the desired dependencies and desired versions of those dependencies to be used. In this case, these are fixed versions. It typically lists direct dependencies unless you do go mod tidy, which then will then also pull in indirect dependencies. But for Ruby developers, the equivalent of this would be like a gem file, which indicates here is the version of the package that I want to use, or here's the name of the package I want to use, plus like some sort of constraint that describes what range of versions I'm comfortable upgrading to within this program or project. And the second file that I want to talk about next slide. There we go. All right. And then the second file I want to talk about is the go.sum file. And this is more of a human or machine readable file, which answers the question of like, what dependencies are we currently using and what versions of those dependencies? So this will include your direct dependencies that you've listed in the manifest file, plus any indirect dependencies and any transient dependencies, all dependencies. This is like a full catalog of all dependencies and versions. And you can look at this file and see like each line is actually delimited by spaces. And there's 3 segments to each line. The first segment is the registry/name, so the location or the name of the package. The second segment is the fixed version of that package to use. And the third is a digest prefix with a key that describes what type of digest it is. So the H1 represents a specific type of hashing algorithm, and I don't remember off the top of my head which one that corresponds to. But the two, I guess, more important pieces of this information in this file is what dependency are we using and what version of that dependency are we using. And this is a comprehensive, or meant to be a comprehensive list of all the dependencies in a software project. So, and let's take a look at another example. This one is for Terraform projects. So if I crack open this main.tf file, we'll be able to see that there's 2 different dependencies that I'm sort of declaring that I want to use. The first one is a Terraform provider. It's the HashiCorp/AWS Terraform provider. And you can see that the source doesn't specify a registry host, so we're using the default of registry.terraform.io. And then we specify a version range, in this case, of ~waka 3.0. So this is like the pessimistic version constraint that says that I'm happy with any sort of the latest version available that satisfies this constraint. And so this constraint says that any version range or any version that is within the range of 3.x.y up to but not including 4.x.y or a.c or whatever is eligible, right? And so when Terraform attempts to pull in the dependency that satisfies that constraint, it's going to look for the newest version of a dependency that satisfies that constraint. And so if the newest version in the 3.0 series is 3.1.0, then that's the version that it will choose. And the second example at the very bottom is the declaration of a Terraform module. You can see in the source declaration, we're actually specifying the registry host as well. So app.terraform.io under an organization or namespace, example-org, yada, 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 and then the actual module name, as well as another pessimistic version constraint. So anything within the 1.x.y range is eligible or would satisfy this version constraint. Let's take a look here. So to summarize, this file is useful for developers for declaring what dependencies they want to use and the range of versions of those dependencies that they're comfortable pulling in. This allows developers to exclude things like major version upgrades, which might require input on their side. And the second part of that is the terraform.lock file, the terraform.lock.htcl file, which is the machine-generated file that's generated from trying to satisfy the constraints defined in the manifest file, that main.tf file. So if we look at this file, we can see that the Terraform provider is declared using its fully qualified name, reg.terraform.io/HashiCorp/AWS. The fixed version that this particular lock file is pinned to is 3.47.0, and the constraint that was used to resolve that version was the ~waka 3.0. So at the time that this lock file was generated, the newest available version of that particular provider that could satisfy the constraint of 3.0, the ~waka 3.0, was 3.47.0. If we were to go look at the registry catalog today, it's possible that we might actually be able to find a newer version of the HashiCorp AWS provider that could also satisfy that same constraint. So for example, if there's a 3.48.0, that would definitely satisfy this constraint. And so we could get Terraform to resolve that. Now, updating all of these dependencies is quite a bit of work, right? So one thing is to keep a track of the full catalog of dependencies in your software program, the current versions of them, as well as all versions that are being published, the reasons for those publishing, the reasons that those dependencies are being published, and then also choosing which ones to update. Now, typically you want to update dependencies that are backwards compatible, most especially like bug fixes. But Dependabot can take care of that for you. So instead of you having to monitor and keep track of all the things, Dependabot's got your back. And you can use it today for keeping your Go mod projects up to date, as well as your Terraform projects. So let's do a quick demo. And let's go ahead and take the same project we've been working on from the beginning, and let's see how we can configure it so that we can tell Dependabot to start keeping this project up to date. And it starts with a configuration file. So if we create a dependabot.yaml file, we can specify a couple pieces of information. One is like the package ecosystem that this particular project uses. So in this case, it's a Go module project. The root directory of the project source code relative to the root of the Git path, and then how often we want to keep this project up to date. And once we've created that file, we can commit it and push it up to GitHub. And Dependabot will detect that this configuration was pushed up, and then we'll take action and try to keep your software projects up to date. Excuse me. And so there's different, in a monorepo, you could actually configure this to monitor multiple package ecosystems, pull from different directories if needed. In the simplest case, we've just got one package ecosystem, and it's at the root directory, and we're going to check for updates on a daily basis. All right, so when Dependabot kicks in, If it determines that there is a newer version of a package that's available that meets the criteria defined in version constraint, it'll go ahead and create a pull request with necessary changes to the go.sum file and any other manifest files that are affected. But on top of that, it includes like this nice metadata that tells you here are the items in the changelog that are relevant, and here are the commits that are relevant. It gives you the version numbers of the current version to the destination version. And so this pull request provides a lot of useful context and information for determining whether or not it's safe to update a software dependency. And this automated process allows us or frees us up to focus on delivering features in our projects rather than trying to stay up to date on the latest versions of each of the different packages that we depend on. It also provides a lot of useful context so that we can do this with all the necessary information for historic reasons as well as for auditing purposes, etc. Now, there are times where you might be curious to see like how Dependabot determines what version to use. And this is where you can go to the Insights tab, click on Dependency Graph, and then choose the Dependabot tab. And you'll be able to see a list of each of the configured ecosystems for the repo. And if you click on the last updated link, we'll be able to see the detailed log. And so in this case, we can see that the latest version that we detected was 1.8.1, and then we upgraded logrist from 1.0.6 to 1.8.1 because we made that determination that this is a valid update. We can also do this for Terraform projects for both Terraform providers as well as Terraform modules. This will update the Terraform lock files if that is checked in. So in this particular project, we've got a few different things in this project. That main.terraform file here is really the same one that I showed you earlier. It's got a dependency on a provider and a module. And we can see that in our GitHub Dependabot configuration, we've got a private registry configured that this Terraform update job is configured to use. And so this will actually go pull the latest metadata and versions from a private registry and keep our dependencies up to date using that as well. And again, we can look at the changelog and all the commits associated with that to determine whether or not we want to update the Terraform provider to a newer version. And yeah, thank you to Dependabot, right? And so if you've got dependencies, consider Dependabot. It can keep your older projects feeling young and nimble, like your younger, youthful greenfield projects. And the effort is really dependent on the configuration. So if you've got more questions or you're interested in learning more, check out docs.github.com here. We support multiple package ecosystems. We have example configuration for how to configure different types of scenarios for your projects. So as you can see here, the list of package ecosystems that we support is fairly comprehensive and continuing to grow. So Dependabot's here for you, to keep you up to date, to free you up to do all the good things and deliver more software. And so please consider Dependabot for keeping your Terraform projects up to date. That's it for me. If you got questions, look us up, github.com/Dependabot. Thanks for having me.